Hello YouTube. In this video we're going to be discussing how to sketch absolute value graphs which look like V's, and after you probably watched my last marathon video on what the heck they look like in general. We learned a lot of things about absolute value graphs, starting with the fact that all absolute value graphs, okay, are of the form, okay, we can write this out here, we'll do it in blue, try to squeeze this in here. They all look like this: y equals some a value times the absolute value quantity x minus h, and then we have a plus k on the outside. Those aren't parentheses, those are absolute value bars. But we know some things about this graph just by looking at the equation, starting with this. When we sketch these things, the first thing we're going to want to do is identify a, h, and k. And notice here that I say h is lying, okay? So the reason why is because when we graph this, we're going to graph our vertex first, and we need to know where the vertex is. So we say the vertex, make sure we know this here, the vertex is always at h comma k. So whatever our h value is and whatever our k value are, that tells us respectively the x and y value of our vertex, okay? I say h is lying because, here's the reason why. I always get this question. Because there's a minus in the formula for this equation, okay? And because this minus is right here, whatever h tells you, it's actually backwards of what it's telling you. And you notice I'm not saying k is lying. K actually has a plus in front of it. So k says what she means and means what she says. So we can identify a, h, and k first, and then go through this process here. So let's just kind of run through some. I mean, these are pretty straightforward. So we say on letter A down here, letter A, we say let's go ahead and start by identifying what's our a value, what's our h value, what's our k value, and then discovering some things from here. So we say a, in this case, a is this number out in front of the absolute values. We say it's 2, or 2 over 1. We could say h in this case. Now remember I said h is lying, so if this says minus 4, we actually are going to imply we're taking away a positive 4 as a positive form. And then k in this case is 3. So what does this tell me about my graph? Well, we've already done step 1 up here. If you're taking notes, these are good steps to write down. But we say step 2 is let's graph our vertex. So we say our vertex. Where's our vertex? Well, I've given us the note that our vertex is at h comma k, and we've already discovered h and k. So it must be the case that our vertex is at 4 comma 3. 4 comma 3. So we're going to go ahead and proceed over to 4, 3. So we say 1, 2, 3, 4. We'll go up 3, 1, 2, 3. So here's our vertex right here. And as a matter of fact, it's always a good idea to label this. Now I happen to know because our a value is positive, this is going to open up. So I'm going to go ahead and label it kind of underneath here. But we say vertex is at 4 comma 3. Now step 3 is this. It says, well, we're going to find our equation of and graph our axis of symmetry. And we say the axis of symmetry is that vertical line that runs through the vertex. Okay, so it's this vertical imaginary line that runs through the vertex. And it basically just says, hey, our graph looks the same thing on the left of this line as it does on the right. And this has the equation x equals 4 in this case. Notice that specifically our x value is 4 here. But the way I can know this in general is I say, well, it's got to have the same x value as the x value on our vertex because it goes through the vertex. Okay. And in step 4 it says, well, from our vertex, we're going to use our a value. Okay, so in this case we said, well, a was 2. We're going to use our a value like a slope to find 2 points on the graph, and we're going to make our letter v. So for example, we're saying a is 2. We're going to say 2 over 1. And when I mention use it like a slope, that just means from our vertex here, we're going to go up 2, so up 2 to a height of 5, and over 1 to the right. We say up 2 over 1, this point's on my graph. Okay, so what I know is this: the right side of my graph has to look like this. But because it's symmetrical about this vertical line that we drew in that axis of symmetry, I know that it also goes up 2 and left 1 because this point has to be symmetrical with the point that we drew using our a value. And we just say simply put, this is the graph of, we should label, y equals 2 is an a value, x minus 4, that quantity, plus 3. So we'll go through a few more here, and then we'll type them in over on GeoGebra and get a good look at what they would look like if I'm not drawing these by hand. So running through this one up here, we say, okay, so let's get started. We say a is out front, h is in here, k is right there. So a, in this case, a is, well, I notice a negative out front, but negative what? Well, we say it's negative 1. Negative 1. Okay, so h. Now h says minus 1 in here, so I'm going to write plus 1. It's positive 1. We say k. So k is this value on the outside of the absolute value expression. We say, okay, so that's also positive 1. So what do we know so far? Well, we know the vertex is at hk, h is 1, k is 1. We also know the axis of symmetry. Axis of symmetry, okay, has to go through the vertex and is this vertical line, so x equals 1 because, well, that's the same x value as the vertex. So we're going to sketch this. Always start by sketching your vertex first. So we say 1, 1. Here's our vertex. We're going to draw in our axis of symmetry next, okay, and label that. We say x is 1. Our vertex here is we're going to label this up here. We say vertex is 1, comma 1. It just tells our audience where we're at. And we say, now my a value is -1. If we're going to treat that like a slope, we'll put it over 1. We say, okay, so down 1 over 1. So if I go down 1, right 1, I actually land right here on the x-axis. We say, okay, so here's my graph. Try to make this decently. So here's the right side of my graph. It also has to go down 1, left 1 then, because it's symmetrical. And there's our graph of y equals negative absolute value x minus 1 plus 1. Moving right along, just a moment here. Sorry about that. My video's done. Okay, so take a look at this guy here. We say, all right, a. Looks like we have an a value that is actually a proper fraction this time. It's going to, if you look at this like a slope, it's going to do more running than it is going to do rising, okay? We say h. H in this case, I don't notice anything in here with my x, so we're going to go ahead and say h must be 0. And k is always the value on the outside of the absolute value bars, and it doesn't lie, so if it says -2, it means -2. So now we say, okay, so the vertex is at hk, so it must be at 0, comma, -2. Our axis, okay, axis of symmetry, that must be at x equals 0 because it goes through our vertex, through that x value. Say, okay, so graphing this, start with your vertex. We're going to go 0, comma, -2 right here. And then we're going to use our axis of symmetry, which goes through this, x equals 0. And our a value was up 1 over 2. We'll go up 1, right 2. Okay, it's like a slope. Here's the right side of our graph. So we have a wider graph this time. But since it's symmetrical, we also have to go left 2 at that y value there. We say, okay, so there's my v. There's my v. Not a bad graph. And then, we would label this. And then last but not least, we say d. Okay, so d, kind of funky here because I'm giving you an a value up front here of -3/2. So we can already imply this sucker is going to open down. Every time we have a negative a value, it's like the slope on the right's going downhill, it's falling. This whole thing is going to fall downhill. It's going to go downhill. So we say -3/2. H, I don't notice anything in here with my x, so h must be 0. And I don't notice a k on the outside of here either, so we say 0, 0. So what this means is this particular absolute value graph is centered at the origin and has an axis of symmetry of 0. This is our axis. Okay, so we say graphing this puppy, we say, all right, we'll start at 0, 0. Axis of symmetry we said was x equals 0. If you can see that there, runs through here, x equals 0. And then from the vertex, which we should be labeling, vertex 0, comma 0, we're going to go down 3, right 2. Just use that a value like a slope. Okay, so if we went down 3, right 2, since this is symmetrical about our axis, we better go down 3, left 2. So down 3, left 2. So we say, okay, so here's our graph of our absolute value. Yeah, that's basically how you graph these absolute value bars or absolute value graphs. And I know I said we pop over to GeoGebra, but I think that's unnecessary. You guys can see these graphs just fine. So enjoy.